So welcome to the new video of this playlist. This video we will cover what are significant figures. First we will see its definition. In any measurement the accurately known digits and the first doubtful digit are called significant figures. In other words, a significant figure is the one which is known to be reasonably liable. If above mentioned measurements are taken by a better measuring instrument which is exactly up to 100 of a centimeter, it would have been recorded as a 12 point centimeter. We'll see its explanation over here. As stated earlier, physics is based on measurements, but there is an uncertainty in the values of measured physical quantities. One reason is the type of instrument. Why is there any uncertainty? We know that every measuring instrument is calibrated to a certain smallest division, and this fact put a limit to the degree of accuracy which may be achieved while measuring it. So here are some informations that age of universe, age of earth, one day equal to second, how many seconds, 1 year equal to how many intervals, then heartbeats, period of audible waves, period of vibration. These are all MCQs. Now we'll see some important rules of significant figures. However, all digits, first rule is that all digits 1, 2, 3, 4, 5, 6, 7, 8, 9 are significant. All a zero between two significant figures is itself significant. So first rule is that if we write 1, 0, then I will write 2. So first rule says that a zero between two significant figures is itself significant. So this zero between 1 and 2 is significant. Zeros to the left of the significant figures are not significant. For example, none of the zeros in left of this 4, 6, 7 is significant. Neither point to this 0 is significant. Zeros to the right of a significant figure may or may not be significant. In decimal fraction, 0 to the right of a significant figure are significant. For example, all the zeros in 3.570 or 7.4000 are significant. However, in the integers, these numbers are not determined by accuracy of the measuring instrument, so these may or may not be significant. When a measurement is recorded in scientific notation or standard form, the figures other than the powers of the 10 are significant figures. For example, a measurement is recorded as 8.70 exponent 4 kg has 3 significant figures. In multiplying or dividing a number of significant figures in the product or the quotient not more than the containing the least accurate factor, the factor containing the least number of significant figures. For example, the computation of following calculator. For example, if we have such value which is the multiple or the division of 2 or 3 values, the product is this one. So the least accurate in the above calculation has 3 significant figures. The answer should be written up to 3 significant figures. After point we will write 3 significant figures to report the answer. The other figures are insignificant and should be deleted. While deleting these figures, the last significant figures to be retained is rounded off to the which of the following rules. If the first digit which is being dropped is less than 5, the last digit retained should be remain unchanged. If the first digit drop is more than 5, then the digit is to be increased by 1. For example, if the digit to be dropped by 43.75 is rounded as 43.8 because the last significant figure is 5. So we will increase this by 1. Next one is 56.8546. So the last significant figure is less than 5, so we have rounded it as Similarly, 671, 640 is 1 dash 6 0, and we see that the last digit is multiple. Next one is 64.350. This is rounded as 64.4. So this is the another rule in which we will see when the numbers are being divided or subtracted. For example, when we will add these values, the answer is 75.523, but we will report it up to one decimal. In this case, the number 72.1 has the smallest number of decimal places. We will go with this smallest number of decimal places. We will report our answer up to this number having the decimal places. For example, this number has only one decimal place. We will report our answer as 72.1. Similarly, this one we will know here. Next one is precision and accuracy. For that, there is a short question: how mass can be converted to energy? Mass can be thought as a form of energy. In fact, the mass is highly concentrated form of energy. According to Einstein's famous energy equation, E is equal to mc squared. E is the energy, m is the mass of substance, c is the speed of light. According to this energy, this equation, 1 kilogram mass is actually equal to 9 exponent 16 joules energy. This is an important MCQ and short question as well. So first of all, we see what is precision. A precise measurement is one. This is the difference between precise and accuracy. Precision and accuracy or precise or accurate measurement. A precise measurement is one which has less absolute uncertainty, and an accurate measurement is one which has the less fractional or percentage uncertainty. We will see this in description or explanation. In measurements made in physics, the term precision is and accuracy are frequently used. They should be distinguished. The precision of a measurement is determined by the instrument or device being used, and the accuracy of a measurement depends upon the fractional uncertainty or percentage uncertainty in that instrument. So this is the example of fractional or absolute uncertainty. We will see this in our next video. This is the important information. Color printing uses just 4 colors: cyan, magenta, yellow and black to produce entire range of color. All these colors in the books have been made from these 4 colors. This is the important MCQs. So now we will see the example of this precision and accuracy. For example, when the light of an object is recorded as 25, length of an object is recorded as 25.5 cm by using a meter rod having the smallest division in millimeter. It is the difference of two readings of the initial and final positions. The uncertainty in the single reading is discussed above before is plus minus 0.05 centimeter, which is now doubled and is called absolute uncertainty, equal to 0.1 centimeter. Absolute uncertainty in fact is equal to the least count of the measuring instrument. Absolute uncertainty is the least count of the measuring instrument. When now this is another example solved, but we will see this what there is written here. Whereas the reading 0.45 centimeter taken by vernier calipers is more precise but less accurate. The reading which is more precise is always less accurate. We have already seen a precise measurement is one which has less absolute uncertainty, and an accurate measurement is one which has less fractional uncertainty or possibility. So this is all from this video. We will see next assessment of total uncertainty in the final result.